Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is examples on moment skewness and kurtosis. In last lecture, also in previous lecture, we discussed some examples on moment skewness and kurtosis. Now one more example on moment skewness and kurtosis. With the example, calculate the first 4 moments about the mean of the given distribution. Also find beta 1 and beta 2. Here the data is given. The data is in the form of frequency distribution, that observations with frequencies are given here. Now, our aim is calculate the first 4 moments about the mean. To find the moments about the mean, first we have to find out the moments about arbitrary mean. Means you first find the raw moments, and then using the relation between moments about mean, means central moments, and raw moments, you can calculate the first 4 moments about the mean. So our first aim is you calculate the raw moments using the frequency distribution. Now how to find the raw moments using frequency distribution? In previous lecture, when we have started this 3rd unit statistics, there discussed about raw moments. The general formula to find the raw moment is here. See, mu r dash is equal to summation fi into d raised to r upon n. Now this d is nothing but x minus a. Xi minus a. A is any value from the observation column, and n is the summation of f, summation of frequencies. Okay, we are going to use this formula here to find the raw moments, first 4 raw moments from the given frequency distribution. So this is your data is here. Now you construct the table. First column, variable column, observation column. Second, frequency column. Third, you construct here the column D. D is equal to x minus a. A is any value from the variable column or observation column. We try to take the middle one value here. Suppose a is equal to 3. So your D is x minus 3. Now you do the calculation. D is equal to x minus 3. So this 2 minus 3 is minus 1. 2.5 minus 3 is minus 0.5. 3 minus 3 is 0. 3.5 minus 3 is 0.5. 4 minus 3 is 1. 4.5 minus 3 is 1.5. 5 minus 3 is 2. This is the third column D. Then the next column is F into D. F into D, this frequency column into D. Multiplication of these 2 columns. Do the calculation here. 4 into minus 1 minus 4 and 36 into minus 0.5 minus 18 and so on. Then FD square. FD square means F into D square. This is the column D. You take the square of D, you will get D square into F. So this is the calculation here of FD square column. FD cube, you take the cube of D. Here, this is the D column. Take the cube of D and then multiply it by F, so that you will get FD cube here. Then FD raised to 4. F into D raised to 4 means you take the 4th power of D into F. F into D raised to 4. This is the calculation here. Then in last you do the addition of all values, means summation F is 3110, summation FD is 173, summation FD square is 235 minus 5, 235.5. FD cube is summation FD cube is 295.75. Summation FD raised to 4 is 444.375. Summation means addition of all the values in the respective column. Okay. Now moments about any value a is equal to 3. Our arbitrary mean means a is here 3. Now moments about any value 3 are given as moments about any value means raw moments. Raw moments formula for first raw moment mu1 dash. The formula is summation FD upon summation F. Summation FD is here. You can check the formula here. Summation FD is 173. You put 170 upon summation F is 310. You do the calculation. It is 0.5580. Mu2 dash summation FD square upon summation F. Put here the value of summation FD square upon summation F. You calculate, simplify it. The calculated value is 0.7597. Then you find mu3 dash. You put mu3 dash is summation FD cube into summation F. Put here the values from the table and you will get the value of mu3 dash. Similarly, mu4 dash is summation FD raised to 4 into, summation FD raised to 4 upon summation F. Put here the values and the calculated value is 1.4335. Okay. So these are the first 4 raw moments about any value 3. Now from these raw moments, you can find the central moment, means moments about mean. Now moment about mean, that is central moments are given as, you know the relation between central moments and raw moments. So first central moment, mu1 is equal to 0, it is always 0. Mu2 is equal to mu2 dash minus mu1 dash whole square. Now from these first 4 raw moments, you put here the values of mu2 dash and mu1 dash, and then calculated value is here of mu2 0.4483. Similarly, find mu3 and mu4. The formula is there. You put the values of raw moments there only. You simplify it, and then you will get the value of mu3 and mu4. Mu3 is 0.0298 and mu4 is 2.4762. Okay. Now from central moments, you can find the values of beta 1 and beta 2. Beta 1 is coefficient of skewness. Its formula is mu3 square upon mu2 cube. You put here the value of mu3 and mu2. These are the central moments, third and fourth central moments. Put here the values, simplify it, and beta 1 is 0.0099. This value is very small. It is near to 0. So the curve is slightly positively skewed, or is near to general shape, normal shape. That curve shows symmetry, but slight positive skewness is there because its value is 0.0099. Beta 2 is mu4 upon mu2 square. Put here the value of mu4 and mu2. Simplify it, and the calculated value is 12.3273. So this value is greater than 3, 12.32. And so the curve is leptocuretic. The conclusion is the curve is leptocuretic. So this is the example of moment skewness and kurtosis. In previous lecture also we have discussed an example on moment skewness and kurtosis. In previous example, first example of moment skewness and kurtosis, that raw moments were given. We have calculated only the central moments and beta 1, beta 2. But here in this example, we have given the frequency distribution, and from frequency distribution we have calculated raw moments first, and from raw moments we have calculated central moments about mean. And after finding the moments about mean, we have calculated the coefficient of skewness and kurtosis, that is beta 1 and beta 2, and concluded about the skewness and kurtosis here. So this topic, moment skewness and kurtosis, is over here. Now the next topic is correlation. Now, what is correlation? Correlation, bivariate distribution. In correlation, what is bivariate distribution? The distribution for one variable x is known as univariate distribution, and the distribution which involves more than one variable is known as bivariate distribution. Bi means 2. There are 2 variables, x, suppose x and y. Then if the distribution involves 2 variables, then that type of distribution is bivariate. Univariate means there is a single variable x. If a change in one variable x affects the change in another variable y, then the variables are said to be correlated. There is a mutual relation between the 2 variables, then we say they are correlated. Okay. Now to calculate the coefficient of correlation, to measure the correlation between 2 variables, there is one formula called Karl-Pearson coefficient of correlation. Karl-Pearson invented it. So the name is Karl Pearson coefficient of correlation. To measure the intensity or degree of linear relationship between two variables, Karl Pearson developed a formula called correlation coefficient. Correlation coefficient between two variables x and y is denoted by xy, and it is defined as, see, the notation for coefficient of correlation is small r. We denote it by the letter small r, and it is the correlation between two variables x and y. So in bracket write x comma y. So this is the proper notation of coefficient of correlation. R of xy is equal to covariance of xy upon sigma x into sigma y. Sigma x, standard deviation of x, into standard deviation of y. Now the formula for covariance of xy is equal to 1 upon n into summation xy minus x bar y bar. 1 upon n. N is number of observations. Summation xy means you construct the table, and in that table one of the column will be x into y, x multiplication y, and that you do the addition of all the elements in that column. That will be your summation xy minus x bar y bar. X bar is the arithmetic mean of x and y bar is the arithmetic mean of y. Now sigma x and sigma y. Sigma x is the standard deviation for x, and the formula is, it is equal to under root summation x square upon n minus summation x square upon n minus x upon n whole square, and standard deviation of y is equal to under root summation y square upon n minus summation y upon n whole square. Okay, so these are the results to find the coefficient of correlation. So after putting the value of covariance, standard deviation of x, standard deviation of y, we have this formula, R coefficient of correlation. Means here in this formula, R is equal to covariance of xy upon sigma x, sigma y. Here you put all the values, means covariance of xy, sigma x, sigma y, and then you will get this formula. Okay. Now the example on coefficient of correlation. The example is here. Compute the coefficient of correlation for the following data. Here, the data is given. The observations of x and y are given. We have to find out the coefficient of correlation. Now construct the table. The first column x, second column y, third column x square, fourth y square, and fifth one xy, x into y. You do the calculation. X square means the square of all the elements in x column. Y square means square of all the elements in y column. X into y means the simple multiplication of x and y. 10 into 18, 14 into 12, and so on. Construct this table, and after finding all the values, you do the addition of all, means summation. Summation of x is 120. Summation of y is 126, means addition of all the elements in column y. Summation x, addition of all the elements in column x, it is 120. Summation x square, addition of all the elements in column x square, it is 2680. Summation y square, addition of all the elements in column y square. Summation xy, addition of all the elements in column xy, it is 2768. Okay, after finding the summation values, you first find the arithmetic mean for x and then arithmetic mean for y. The formula is here. Arithmetic mean for x, here frequencies are not given, only the observations are given. Observations of x variable, observations of y variable. Means you assume here the frequency of every element is 1. So to find the arithmetic mean, this formula is very simple. You just do the addition of all the observations in x column and just divide it by number of observations. You will get arithmetic mean for x. Same for y. So x bar is equal to summation x upon n, is 20, because summation x is 120 and the value of n is here 6. So it divided by 6. 120 divided by 6, it is 20. So y bar is equal to summation y upon n. Summation y is 126 divided by 6. And because n is equal to 6, 6 entries are there. 1, 2, 3, 4, 5, 6. So n is equal to 6, and so y bar is 21. Okay, so arithmetic mean for x is 20, arithmetic mean for y is 21. Now, coefficient of correlation is given by the formula to find the coefficient of correlation is Rxy is equal to covariance of xy upon sigma x sigma y. I'll discuss it here. The formula. This is the formula of coefficient of correlation. You write this formula and then put the values in this formula. Covariance of xy is 1 upon n into summation xy minus x bar y bar. Sigma x standard deviation is this square root. Sigma y standard deviation of y is this square root. Put all the values 1 by n. N is 6. 6 entries are there. Then summation xy is here. You see the table. What is summation xy? Summation xy is here. Summation of xy is 2768. So you write here 2768. 2768 minus x bar y bar. X bar is 20 and y bar is 21. Arithmetic mean for x bar and y bar. Here is x bar is 20, y bar is 20. Put here that these values 20 and 21 upon under root summation x square. Summation x square from the table. See here the table. Summation x square is 3276 and summation y square 2680. So from the table you write the values here. Summation x square is 2680 upon n is 6 entries are there minus summation x upon n is nothing but the arithmetic mean. Means this is the value of x bar. Summation x upon n is nothing but x bar. It is 20. So right here summation x upon n is equal to 20. 20 square. Another square root. Summation y square from the table it is 3276 upon n. N is 6 minus summation y upon n. Summation y upon n is 21. 21 square. Okay. So put here all the values and then you just simplify and calculate the values. And the calculated value after putting all the values, you calculate the final value. It is equal to 0.5904. So this is the coefficient of correlation between x and y here in this example. You always remember that the coefficient of correlation, its value is always less than 1. If your answer is more than 1 or greater than 1, then it is wrong. You again check or go through the solution and correct it. Okay, you always remember that coefficient of correlation, its value is always less than 1. So this is the example of coefficient of correlation. You remember that there are only 5 columns we have to construct while solving the problem of coefficient of correlation. First is x variable column, y variable column, then x square, y square, and then x into y. And you just use this formula to find the coefficient of correlation. Okay, so the topic coefficient of correlation is also covered here. Okay, in next lecture we are going to discuss regression coefficient, regression lines. So this today's session is over here. Thank you.